guys, this is the chemical of the month. I'm Chris Aguirre. This is Joe Gorman. Get your charts, get your NIOSH guide, bring the meters so you can look at the meters and link them visually with the hazards. And here we go. You get dispatched on a call. The name of the chemical is nitrogen dioxide.
So there's a tank truck that's rolled over. You get people screaming that there's an orange cloud coming out of the back of this truck. And if you get the wrong thought process in your brain, you could say to yourself, Chris, nitrogen dioxide, well, nitrogen's in the air. Carbon dioxide's in the air. No big deal. But it doesn't work that way. You got to take the chemical, look at the first name, look at the last name, and then come up with hazards. And if you can remember this about a hazmat call, hazards drive the hazmat call. So the first thing we have to try to do is come up with the hazards of nitrogen dioxide. So if you remember the 4-step system, step 1 is using your charts. So let's get our charts out and let's look at above the line or below the line. Which one is it? Nitrogen dioxide. So go to chart number 2. I think chart number 2 is much easier to use.
Yeah, chart number 2. You look at chart number 2, go down to the ends. You'll see there nickel. You'll see there some of the ends, and then is nitrogen there?
The first name, right? That's a first name box. Is nitrogen in that first name box?
It is not there. So you go to the no, and the arrow takes you to a play. Like in a huddle, you're calling a play. Everyone responding on the nitrogen dioxide, this is above the line. That becomes your standard or your safe operating guidelines. So what does everyone think? What does in the size up, what does nitrogen dioxide look like?
Well, it's an above the line. So all above the lines in size up look exactly the same.
It's a gas. The initial osmosis is 300 feet. The vapors are heavier than air. It's toxic in parts per million. It's flammable in LEL. It's corrosive. What is it, an acid or a base? There's a red X there. Acid. It has fluorine in it, till proven differently. It's corrosive, acid. It's also radioactive, until proven differently. It has fluorine in it.
It reacts, right? We're going to treat every chemical that it polymerizes. They all don't polymerize.
They react with water. It reacts with air.
But for now, size up is we throw all the hazards in that box. Okay, then it says go to chart number 3. So flip over to chart number 3.
You go to chart 3, you go to nitrogen, and you'll see in the first box, can I fit the word nitrogen in some of the syllables in that box? The answer is no.
What about dioxide? Can dioxide fit in that box?
No.
Remember, guys, you want to use the entire name to see if there's a carbon and hydrogen clue there. It can be buried at the beginning. It can be buried in the middle. You'll find it all over. But nitrogen dioxide is a no from the flammable clue box.
There's no carbon-hydrogen syllable in the word nitrogen dioxide. The no takes you to the middle box, which is the first name of corrosive gases. Is nitrogen there? Yes.
Yeah, what color is it?
Red.
Why is it red? Why isn't it blue?
Because the pH of the chemical that starts with nitrogen is red. If it would have been ammonia, it would have been what?
It would be blue if it was
ammonia. And if it would have been fluorine, the F paper would have gone what color?
Color fluorine on there is yellow. So,
so they're all color-coded to the stain of the paper, be it pH or fluorine. So now when you say yes, because nitrogen's there, all units responding to the above the line, you go back on the air, all units responding to the above the line, we're running a red 0, a red 0.
I told you that hazards drive a hazmat call. So if everybody's reading red 0, what are the hazards? The hazards are toxic, flammable, corrosive. Well, if you have any question on if it's going to be an acid or a base, you look at the pH column. And the pH says, it could be blue, it could be a base. It's red, it could be an acid. And heck, it could have fluorine in it. But Chris said earlier, based on the first name nitrogen, what color would the pH paper change to?
Red.
Good, so there you go. We have all the instruments now going from left to right there. Remember the ones with the red background? Those measures hazards that can hurt you or kill you. So all of those have red lights. Red light means stop. You'll notice on version 20 charts, what's on there now is we've added the yellow lights. Based on input from students, people said, well, I don't know, isn't there something between going and not going? Isn't there one that we could proceed with caution? So we put new levels in there. We call those the yellow lights. So yellow lights, you can work, but realize it's dangerous work what we're about to do. So you'll see that on that. So all the instruments, then you go all the way over to the right where it has PPE. PPE now is mission driven. If you remember the older charts, It would just give you an X, which one we recommended. Big X was turnout gear. Sometimes you saw a smaller X for level B. But on this one, since it's a corrosive gas, what are you thinking for PPE? Would you want to wear turnout gear into a gas? Can I walk from point A to point B and avoid the gas? And if I can't, my turnout gear is not the right PPE. So if I'm going into a hot zone, into that orange cloud, I'm wearing a level A suit on this one. But Chris shows up on engine, what were we on, 40? What were you on?
I was on HazMat 17, but I'll put the suppression unit. We're on ladder 17.
He shows up first. What did you have for PPE on ladder 17?
Turnout gear.
So if there's a driver that needs to be rescued in a corrosive gas environment, what's he going to wear?
I'm going to wear turnout gear, and that's the point I want to make. So what's driving this mission? On one, we got the cloud, the plume going over a community, but at the same time, we got another unit focusing on a driver that had an epileptic seizure. He had a grand mal seizure, he's postdictal, and we got to get him out. And you're in turnout gear. So now what are you going to do?
So the guy's alive in the truck, right? So he's in that environment, alive, dressed like I am. Chris shows up in turnout gear and SCBA. Would you bring a hand line in with you on that one?
My God, would I bring a hand line in? Now, are you kidding me? My God. Listen, now, so this is what I got to think. I have to know. Remember, I need to know if when I take this chemical with a fog pattern so that I can remove the driver. I've done it with propane. We can do it with NO2.
Is this going to act like propane? We don't know this right now. All this is going through my thought process because I'm coming up with an action plan. And my action plan, his action plan is he's on his suppression piece, turnout gear. His mission is rescue the driver.
So I'm going to work. All right. I'm working on the rescue.
Half an hour to get there.
And he's going to work on the plug. I got to make a rescue first. So then I go to the book.
Quickly go to the book. We're en route. We're en route to nitrogen dioxide. What did we say it was? Corrosive, flammable, toxic. Toxic, when you're making a rescue, put your mask on. That takes care of it. But corrosive gas. What's it say for corrosive gas in the book, Chris?
It says corrosive gas, that there's no LEL. It reacts with water. It's heavier than air.
What's the DOT number?
And the DOT number is 124. If you go back to chart number 3 and you look at the box, you see that the 124 is in red. It tells you confirmed. My size up is confirmed and verified. That's why number 2 says tweak your size up, which is in your mind, with the facts when you get to the book.
So he's making a rescue right now. One of the things that I would do if I arrived on the scene and had this book quickly, I'd look at the hazard. Is it flammable? Quick, Chris, quick.
Ain't none.
Is it corrosive?
Yes.
Oh man, I'm going into a dangerous environment in turnout gear. I'm not going to screw around when I go into the hot zone. I'm going to pull that driver out. But the biggest hazard I want to know if I'm in turnout gear, is there fluorine in this chemical? That's in the formula.
There's an N and there's an O.
Done. I don't care about the molecular weight right now, but one thing I will care about is my hand line. What's that going to do? What's it say for SOL?
It says reacts. Now, listen, what reacts means it mixes. It mixes, but there's going to be some type of reaction come. And when I look at the note, I always read note. It's Latin for read me. It says note. It reacts with the water coming out of my fog pattern to form nitric acid.
Is that going to prevent you from making the rescue?
It's not.
Because if he waits for my truck to show up in the level A PPE, that driver is going to be exposed to that corrosive gas for how long? I told you it's going to take me 40 minutes to get there. That guy's going to die.
The NIOSH shrill is 1 part per million. We can see a cloud.
What's he wearing for respiratory? The driver.
He's got nothing.
I've never seen a truck driver with an SCBA on.
As soon as you can see color, you're looking into thousands of parts per million. We got seconds to save this man's
So go
life.
ahead. So quick in. 2 people going in. Hand line. Trying to knock that gas down to make it safe. If he does a good job, his pH paper on his mask will not change to red if that fog stream is knocking it down into nitric acid. Do you want to just splash through that crap? Hell no. You want to try to avoid the spill, get the driver, get out, do decon, get him to the hospital, and get his treatment.
Now we're going into overhaul. We made the rescue. He's on his way to ER, and now Joe gets her in a hazmat team. So I did my rescue and turnout. Joe's going in to do plumbing.
So for me, I got all day now. So I get there, I look at the hazard, but do I need all day? I know the hazards already. It's a corrosive gas. What am I wearing to go into the hot zone to fix that leak? I'm not wearing turnout. I'm not wearing level B because it's not gas tight. So I'm wearing level A. And when I go into there, when I wear a level A, is it important to look at permeation data? Right? You guys ever look at permeation? Permeation tells you how long it takes for the chemical to seep through the plastic. What number am I looking for? Greater than 480 minutes for nitrogen dioxide.
So I got two suits. One permeation time limit is 40 minutes. The other one's 480 minutes. Which one would you want to choose?
Obviously we're going to wear the 480, and we go in there, and it's a gas. Right? So think in to fix the leak, but there are people behind me setting up decon. Do I need a 15-step elaborate decon system, catch water for the gas that's getting on my level A suit? I don't need an elaborate system when it's a gas. I can use a fog stream. Would I want to catch it? I guess in case the EPA shows up, but let's think about it. How much of that nitrogen dioxide is going to stick to my suit that when I hit it with water, it's going to make this nitric acid that's going to kill fish, right? So we'll do it, but it's not that big a deal. It's more important to do decon with a low vapor pressure than a high vapor pressure. And look at the vapor pressure of this, 720 millimeters. Remember, vapor pressure, another word for vapor pressure is evaporation. And how fast it evaporates, the higher the number, heck, this will do self-decon. It'll evaporate on its own. So, I mean, this is a fairly easy call. Chris had to risk his life to make the rescue. For me, when I showed up in a level A suit, I can work, that's an easy call, because it's a corrosive gas that's not flammable. I can wear plastic all day. When I get done with my entry, do a quick cursory decon, throw the suit in the garbage.
And another thing we can do, remember, whenever you put on a level A suit, I want you to take your pH paper and your F paper and put it outside, duct tape it to outside of the level A visor, and then duct tape it to the inside. So while you're working in a cloud, where it says hundreds of thousand parts per million, if you get a rip, if you get seeping in through your rear that you can't see, the pH paper will turn. You get out, I've got a compromise inside of the suit.
So that's suit protection,
and
right?
And that same pH paper can also pH the decon water to see if it's contaminated. If it doesn't change pH, you can dump it into the stream. If it's contaminated because it changes red, put it in a recovery drum. Now, you got two recovery drums, plastic and steel. It's a corrosive. Which one would you use? Plastic.
That's why we carry overpack drums that are made out of steel and made out of plastic.
And listen to this, Joe. This is not organic, but it has a IP of 9.75.
So the VOC thing?
Yeah, that thing, that VOC, that stands for volatile organic carbon and hydrogen.
This is a volatile inorganic.
Look.
So it works on that also.
It has nothing to do with carbon and hydrogen.
One of our students have a question for you. They said the R-gas D says 2.62. You don't talk about R-gas D. What is R-gas D?
All R-gas D is when you take the molecular weight, which is 46, and divide it into the weight of air, which is 29, you get 2.6. So I don't even look at R-gas D. I just look at molecular weight. If it's greater than 29, it's going down.
So with R-gas D, what does air equal?
1.
So 2.62 means it's more than twice heavier than air. It's going down. Just another way
so if I take 29 times 2.6, it equals a molecular weight.
48.
That's just, yeah. It's to confuse you. Right, just to confuse you.
Okay, so that's it for this month's edition of the Chemical of the Month. Remember, we did nitrogen dioxide, a corrosive gas, quick in, quick out rescue and turnout gear. HazMat team shows up. It's a level A call. Fix the spill, take care of the leak. Life is good.
Now remember, guys, if you need anything, we can help you. You know, you don't have F paper, pH paper, you don't have a PID, you need a bulb, any type. Remember that when we partnered with Federal Resources, is because we do the training and they supply the equipment. You just call the 800 number, 518-9895. Kara, which is Joe's daughter, will answer the phone, and we're here to help you. We're here to serve you. That's our mission. Remember what our mission is, that at the end of our shift, we go back home to our family.
So you need equipment and training to be successful. So that's how we roll. All right, for now, Chris, signing off for this month.
Stay safe, my brother.
Okay, take care.